Welcome to the Explainer. So today we are decoding something incredibly exciting and super practical. We're looking at the ultimate 13-step roadmap to transitioning into the incredibly high-demand field of AI engineering by 2026. If you've been sitting there wondering how to move past just casually messing around with AI tools and actually start building real enterprise-grade applications with them, well, you are in exactly the right place.
Let's kick things off with a pretty bold mantra that sits right at the core of our source material today. Skip the math degree, ship the system, repeat. I love this because it completely reframes the whole AI conversation. Just a few years ago, working in AI meant you basically needed a PhD in statistics and deep learning. But today, the modern AI engineering paradigm is all about practical tool use, system architecture, and rapid deployment. It's really about taking these incredibly powerful foundation models and shipping real-world value. We've got a lot of ground to cover, so we're breaking this 13-step journey down into 6 manageable phases: the AI engineering paradigm, core AI building blocks, autonomous agents and systems, safety and production scale, the modern developer toolkit, and finally, future-proofing your career.
All right, phase 1, the AI engineering paradigm.
So what does it actually look like to build in the AI era? Okay, I know, at first glance, this complete 13-step roadmap looks like a giant, overwhelming puzzle. We've got nodes and branches shooting off in literally every direction, covering everything from LLM fundamentals to deep software engineering essentials. But don't worry, stick with me, because by the end of this explainer, you're going to understand exactly how every single one of these pieces connects.
Moving into phase 2, core AI building blocks.
Step 1 of our 13 steps focuses right on LLM fundamentals. Before you can build the house, you gotta know your materials, right? You need to grasp how models actually read text through tokenization. You absolutely have to understand context windows, which is actually, scratch that. Think of it more like the strict short-term memory limit of the AI you're working with. You also need to know exactly how sampling works to control how creative or predictable the output is, and get familiar with the new wave of reasoning models. Demystifying these core terms is the absolute prerequisite to everything else we're going to do. Once you know how the model thinks, step 2 is prompt and context engineering. And listen, we're moving way beyond basic chat instructions here. Prompting is a real, clear progression. You start with system prompts, then you move up to few-shot prompting and chain of thought, which literally forces the AI to show its work before answering. Then things get pretty advanced with XML structuring to guarantee reliable outputs and prompt caching to save you serious money and time. Finally, we reach extended thinking for those really complex problems. It is a highly structured science now, not just creative writing. Then we hit step 3, which is where things get really cool: RAG, or Retrieval Augmented Generation. This is how you give an AI access to your private, external data. And the evolution of RAG is just fascinating. You start with the basics of embeddings and chunking up your documents. Then you add re-ranking to get way better, more relevant search results. But the real frontier right now is shifting from classic RAG to graph RAG, and ultimately, agentic RAG. That's where the AI actively decides on its own what data it needs to go fetch to answer a user's question.
That brings us to phase 3, autonomous agents and systems.
So we've given our AI a brain and we've given it memory. Now, we give the system hands and eyes with agentic systems in step 4. This is arguably the most exciting part of the whole roadmap. We are talking about models that use the ReACT framework, reasoning and acting, to literally use external tools. Just imagine setting up multi-agent ecosystems where different AI personas collaborate with each other. We're also seeing the massive rise of computer use and coding agents, where the AI can take control of a virtual environment to execute tasks, aided by new protocols like MCP. It's taking AI from a passive chatbot to an active, working digital teammate. But as you build these active systems, step 5 is a good reminder that things get complicated quickly. AI gateways and routing become absolutely essential. Think about it. If you have an app deployed and OpenAI goes down, what happens? Well, a gateway gives you multi-provider abstraction and automatic fallbacks to, say, an Anthropic or a Google model. It also gives you one central place to manage traffic, route queries to the cheapest appropriate model, and strictly track your API costs. And hey, the real world isn't just a bunch of text, right? Step 11 on our roadmap jumps into multimodal integration. A modern AI engineer has to seamlessly integrate vision, image generation, voice agents, and video generation. Document AI is also huge here. It allows your systems to inherently understand PDFs, charts, and handwritten notes. This is exactly how you create those significantly richer, much more intuitive user experiences. Moving to phase 4, safety and production scale.
Listen, there is a massive gap between a cool weekend demo and a robust enterprise-ready system. You simply cannot deploy AI in the wild without strict defenses. In fact, you can think of Step 6 as a leadership's guide to 5 risks in AI production. To mitigate these risks, you absolutely must have these 5 things: input and output validation, a robust defense against prompt injections where malicious users try to trick your system, PII redaction to protect sensitive personal data, jailbreak prevention, and active hallucination detection. Without these 5 guardrails, your system is just a massive liability.
Combining steps 7 and 8, we hit observability and production AI engineering. Basically, how do you know if your model is actually doing a good job in the real world? You use LMM as judge frameworks and custom evaluations. You need deep tracing to see exactly where a complex prompt went wrong, and for production, you have to master streaming responses, parallel tool calls for speed, and semantic caching. Because out there, every single millisecond counts. That's why managing latency budgets and optimizing costs are non-negotiable skills for sure. When you are finally ready to ship, Step 10 covers inference and deployment. And we've got a whole spectrum of options here. You might start out utilizing frontier APIs like OpenAI or Anthropic, but as you scale up, you'll probably shift towards cloud AI services, specialized inference platforms, or even self-hosting open source models just to maximize privacy and drive down those long-term costs.
All right, Phase 5, the Modern Developer Toolkit.
So what does the actual foundation holding all of this up look like? It's really crucial to contrast Step 12, ecosystem fluency, with Step 9, standard software engineering essentials. Yes, of course, you need to navigate Hugging Face, read the latest research papers, and understand benchmarks. But look at the SWE essentials on the other side: Python async, fast API, Git, Docker, and adding vector capabilities to solid databases like Postgres. The big takeaway here: standard, rigorous software development practices are still the absolute backbone of AI engineering. You are a software engineer first, applying AI as your newest, most powerful tool. Finally, Phase 6, future-proofing your career. Because, honestly, all the technical knowledge in the world means absolutely nothing if you don't know how to leverage it for your own growth. Step 13 is all about career compounding. This roadmap doesn't end with code, it ends with community. The most successful AI engineers right now, they ship publicly. They contribute to open source. They write about what they're learning. They actively participate in communities, and they build in public. This is how you attract amazing opportunities, rather than having to chase them down. It's about compounding your reputation right alongside your technical skills. So why embark on this intense 13-step journey in the first place? Well, there are 5 core pillars holding up the AI era. AI skills are in incredibly high demand across basically every industry. They are future-proof, ensuring you stay relevant as things change. You get to solve real-world problems and have a massive impact. There are diverse paths, meeting many different roles but one shared mission. And ultimately, it empowers you to be the future, to learn today so you can lead tomorrow. Which leaves us with one pretty big question. Are you ready to build the future? We've walked through the paradigm, the core building blocks, the agents, the safety protocols, the developer toolkit, and the career strategies. The roadmap to 2026 is right in front of you. Skip the math degree, ship the system, repeat. It is time to get building. Thanks so much for joining me on this explainer, and I'll catch you in the next one.